Hey guys, welcome back to another episode of Reaktor Toots. My name is Peter, and we're going to be talking about scaling today and scaling different features of our synthesizer and maybe adding some LFOs later on. So cool. Let's say if we wanted to have more dynamic control of our filter cutoff frequency, what can we use to make it a little bit more characteristic? The first thing that comes to my mind would be to add an envelope. Much like the amplitude envelope that we added earlier, this is going to have the exact same parameters. So if you saved your envelope macro, you can recall it just by going into macro, then load, then going to where you keep all your Reaktor stuff, loading it up, and then there you go. There's your basic envelope. Now, right off the bat, I know we're going to need a signal to trigger it, so we're going to use the gate input. So let's just duplicate an input of the macro and then label it G. And then right off the bat, just double click or go into built-in module, go into auxiliary, and then click A to E. And what that basically does is it converts an audio signal to an event signal. Because if you remember, you cannot hook up an audio signal to an event type input. So we're going to need to be doing that in a little bit. So just to save time, hook that up right now. And now you'll see the output is changed to red. Awesome. So cool. If we wanted to adjust this filter cutoff input using both the filter cutoff knob and this envelope, mathematically speaking, we just need to combine these two together. So the most basic module to do that would be in the math category, and then just click add, because when it comes down to it, we're all working with numbers. This filter cutoff frequency is set at 64, and then we would want to change that in tandem with the envelope. So cool. Now if we tried to hear the effect of this envelope, we would probably not notice any audible differences. And that is because of the signal that's triggering the envelope. Because if you remember, if we go over to the G input, it basically says that the signal that goes in here will determine the envelope's peak value. And since we're using the MIDI gate object module to trigger this, that only goes from 0 to 1. So the highest the envelope will be a value of 1. And a value of 1 added to the filter cutoff frequency knob right here will not produce an audible difference, so we need to scale it. And to scale something, we need to use not the add module, but the multiply module. So go ahead and hook up the envelope into the multiply module, and then right click and click create control, and then hook it back up into the add module right there. Let's label this ENVAMT, and then change the range to something along the lines of 77. And let's see if we did everything right. So this is the filter envelope right here. Let's actually rename that filter. And let's try it out. And what did I do? Oh, okay. We need to attach the gate input into the filter macro input G right there. There we go. So now we can get some cool plucking effects because there's an envelope affecting this parameter right here. What I like to do is include a negative value range as well. Doing so will invert the envelope, which could produce some pretty cool effects. So cool. If we wanted to use an LFO to modulate this filter cutoff as well, that's easy enough to do. We would scale it the exact same way. Let's make a new macro. Call it LFO. Hook up the output into the input of the filter macro right there. Just label that LFO. And label that G because, just because. And go into it, and then go into built-in module, LFO envelope, and then LFO right there. Awesome. So LFO stands for low frequency oscillator. In other words, it's a signal that oscillates at a low enough rate for it to be inaudible, but it is low enough to be used as a control signal. So it is the thing that makes your basses wobble so very much. Let's hook up the sine wave output to the output of the macro right here. Let's have an adjustable parameter to modulate the frequency of the LFO. You can label it speed if you want it to make it a little bit more decipherable. And for now, let's have the amplitude of the LFO 1, because this is a global LFO, and it would make things a lot simpler to have a global LFO oscillating at 1 amplitude. So then you can scale it different amounts for different parameters. Cool. So if we go back into the filter macro, we see we have our LFO input right there. Let's just duplicate all this junk because that's how we scale the thing in the first place. Hook up the output of this into the input of the add module right there, because they're all going to be modulating the filter cutoff frequency in tandem. And quickly rename that to LFO. And then have the minimum be 0 for reasons I will explain later. Maybe change that to 70. And let's see if we got it right. Excellent, cool. That works exactly the way I thought it would. Sweet, so we didn't want a negative value for the minimum LFO amount parameter, because having a negative value would just flip the phase, and that wouldn't really have an audible effect. Like, it kind of would, but it wouldn't really make that much sense, in my opinion. There's a phase parameter on the LFO module itself, so if you wanted to mess around with that, you can do that pretty easily. Cool, so yeah. There's an input on the LFO module called sync, which basically restarts the signal when a positive value goes into it. So instead of the LFO sounding like, if I were to just press a key really fast, the LFO is still going. If I wanted to have it synced up to the gate, I just hook that up there, and then I get that kind of effect. Cool. Sweet. There are situations where both sound good, so if you just wanted to make it an optional feature, that's easy enough. Just go into panel and then switch. Rename the switch sync, and then yes, please. And now we have our own little LFO macro right there. Excellent. So cool, that was scaling, and those were LFOs, and hopefully you found this helpful. See you guys next time. Tutorial over.